What's going to happen is we are going to start applying trigonometry more and more. For example, we are going to start solving right triangles. What that means is finding either unknown sides or unknown angles in a right triangle. And as you'll see, that has a ton of real-world applications. The right triangle is probably the shape that I use the most as an engineer. In this case here, what we're doing is we're solving for an unknown opposite side, given that we know a hypotenuse and that we know the angle that's opposite that opposite side. We just want to do some algebra here, though. So back in the day, people used to have to either do this very manually, like take out a protractor, measure 22 degrees, make the hypotenuse equal to 15 units, and then use a ruler to figure out what that is. And then after that, people started to create tables of these trig values, and they use those tables to help them solve. In this day and age, though, we have the calculator. And not only is the calculator easier to use and faster, it's also much more precise. Much more precise than a protractor and ruler. So the calculator tells us that the sine ratio is 0.3746. And that is equivalent to x over 15. So Scott, what do you think you would do from there? Yep. Okay, so 15 times 0.3746. That equals x, which is the opposite side. So you can just do 15 times the sine of 22 if you want. Same thing. So the opposite side is 5.62. And one of the things that right triangles are used for is to figure out distances between objects or how tall things are that are too tall to measure. Okay, a lot of uses. All right, next random helper. Melanie, could you help me with number 2?
Sure. You would find the tan of 75 first.
Okay. Tan of 75.
And then you would multiply that answer by 80.
Good. Very good. Melanie, what side would this be in a right triangle? N? Opposite, adjacent, or hypotenuse?
Opposite?
Very good. All right. Alexandra, please step me through number 3.
So you do sine 48 times a, so it's sine 48a equals 7.
Very good.
And then divide
Yes.
7 by sine 48,
Excellent.
which is 9.4.
Well done. 9.42. Okay, so that's the hypotenuse. Next up, we've got James. Cosine of 6 degrees equals 92 over k. Please tell me how to solve for k.
Multiply by k.
Good?
So divide 92 by the cosine of 6.
Oh, sorry. K equals 92 divided by cosine of 6, which is what you said.
And you get 92.51.
Nice. Any questions on 1 through 4? All right. Now you're going to get equations that are like 1 through 4 in 5 through 12. You have to choose which trig function. So it's a fun little game. Natalie, which trig function would you choose for number 5?
Sine.
Yes. It's because you have the opposite side and the hypotenuse.
So
Yep, I'm listening.
sine 35 equals x over 10.
Good.
And then sine 35 times 10 is 5.73.
Good. So multiply both sides by 10 in order to get x by itself. $5.7 is the answer. Next is Jordan. Jordan, could you tell me which trig function you would use to solve number 6?
Cosine.
Good.
So cosine of 54 equals x over 35.
Nice. And
You've done sine of 30.
yeah, you could have. You could have found that this is 36 degrees and used sine. Absolutely.
Okay, so then cosine of 54 is 0.588.
Okay. Keep going.
And then 0.588 times 35
Good.
equals 20.57.
Good. Nice job. Darian, number 7. Which trig function would you use?
I use tangent.
Tangent, yes, because you have opposite and adjacent.
Yeah, so I did tan of 20 is equal to x over 47.
Nice.
And then I did tan of 20 times 47.
Good.
And I got 17.08.
Nice job. And Noi, number 8. Which trig function would you use? Sine. Yep. And can you tell me the rest of the equation? Good. And then? Sine of 16. Mm-hmm. Good. So 4.96. If we're rounding to 1 decimal place, it would be 5.0. Okay? Good. Nice job, everyone. Keep it up. Shirley, number 9, which trig function? Tangent. The equation, please. Mm-hmm. Good. Next step.
Then you would multiply 10 to 65 with 7.5.
Nice.
You get x
Oh,
over
okay.
16.1.
16.1. Very good. Okay. 10. James, which trig function would you use for 10?
Cosine.
Cosine. Good. The equation, please.
Cosine of 51 equals x over 60.
Nice.
off by cosine theta 1 times 60, and you get 7.8.
Very good. Okay. Julie, number 11. Which trig function would you use there? Mhm. Very good. Mm-hmm. 25 over x. I like that better. Okay. Could you tell me how? By 25? That would be illegal. Well, let me rephrase that. If you multiplied sine 36 by 25, then you would need to multiply this by 25. And that's not going to get you anywhere because you'll get 25 squared. And that's not making it any simpler. You can divide both sides by 25. I don't advise that because I've seen so many students, when doing that, think that x is going to go in the numerator. So I would only advise that if you're very fluent in algebra. What I would advise is cross-multiplying. Yeah. So x times the sine of 36 degrees equals 25, because that's over 1. And then you can divide both sides by sine 36 to get your answer, which is 42.5. Yes?
If you want to do it easier, can you just do the reciprocal of sine 36 times 25?
The reciprocal of sine of 36 times 25. Let's investigate that.
It's just, yeah, 1 divided by sine 36 equals x over 25.
This equals the cosecant of 36. We would have to take the reciprocal of the other side, which equals that. Absolutely. Nice job, James. 25 times the reciprocal of the sine of 36. 42.5. You may be wondering, why do we have things like cosecant, secant, and cotangent? It's a very natural question. My belief is that because trigonometry is so old, it's one of the most ancient of mathematics. It predates by millennia things like calculators. What people had were tables of things like sine, cosine, tangent, cosecant, secant, cotangent. And I think that in a case like this, it might be easier to use something like cosecant because then you just have to multiply by it, and that maybe was an easier mathematical operation for people to do back before calculators than division. That's my hypothesis, at least. But I'm really glad that you're thinking along those lines. Good. And one more in that set. 12. Alec, you were called while you were out. Could you tell me which trig function you would use for number 12?
Yeah.
Cotangent? Okay. So tell me what your equation is.
I would do what James would do. I would find the opposite of tangent, so I would do 1 divided by the tangent of 60 degrees.
Okay.
And that's 0.577. And I would just multiply that by 90. I would get
577, and that's equivalent to adjacent over opposite. So yes, I totally agree with you. $52.0. Okay, any questions on 5 through 12? Very shortly, probably next week, we'll be able to get outside and do that lab that I've been speaking of, which is one of the most exciting parts of the year for me. It's not easy in a traditional high school math class to get outside or to do labs, so anytime I can, I relish it. Okay. Some of the things that you'll be doing are figuring out the heights of things that you couldn't normally figure out using this right triangle trigonometry that you've learned recently. So something like number 13. You have a 20-foot ladder. You know how long it is. You know the angle of elevation here. And out of curiosity's sake, or maybe you actually needed to know, how high up the building that could go. Like, for example, if you are a fire person and you need to reach a certain story, you would probably need to know how long of a ladder to take that would give you, or that would meet that need. Okay. Random person, Alexandra. Which trig function would you use for number 13? Don't worry, we'll get her. Vicky, what trig function for number 13? X over 20 equals the sine of 72.
Oh, sorry, cosine?
I like sine better
Oh, wait. Yeah.
because sine is opposite over hypotenuse. Yeah, these things that we call sine, cosine, etc., they're nothing that special. They're just ratios. We've just given them names. You know, it could have been Fred. Yeah. So what would you do next, Vicky?
Then you will find the sine of 72.
Okay.
So, that's 0.95.
Good.
And then set that equal to 2.5.
Good.
Over 1, breaking cross multiply.
Mm-hmm.
And so then x equals 19.
Good. Units, Vicky?
Oh,
Yep. Good. Anyone here an aspiring firefighter? No? My father was not an aspiring one. He was a firefighter before he retired. And what he told me was that for every 4 feet you have to go up a building, your ladder has to go out 1 foot. And he wanted to know what was the angle of inclination. And he asked me because I teach trigonometry. Now you can answer my father's question. I'm not making this up. How could you figure this out? And That is a false statement, right? Right?
Yeah, tangent is correct.
I like that better. That is a true statement, except not. Sometimes I speak too soon. You'll have to forgive me.
So it'd be 4/1.
4/1. There we go.
So it'd just be 4.
Okay? We're getting there, Darian. My father wants the angle
Oh, you do the inverse yeah?
of.
The inverse of
Nice! You can do it. Second, tan of 4. That's the answer my dad was looking for. 76 degrees. Okay. And they do that to maintain safety while maximizing how high up the building they can go. They try to maintain a 76-degree angle between the ladder and the ground. Okay? So I'll give you real-world applications when I'm aware of them. Good. 14. Noi. Which trig function would you use to solve for x in number 14? Sine? Try again. Did you say tan? So look, you have the opposite and you have the adjacent, so tan is a great idea. You may not think that 2 degrees is big, but if you're talking about very long distances, like 700 miles could be considered that, 2 degrees matters a lot, as you'll see here when you multiply 700 times the tangent of 2 degrees. They end up being 24 miles off course. Okay?